Welcome to my class of Mobile Ad Hoc Networks. My name is Aparna Mishra, Assistant Professor in EC Department at IIMT College, Greater Noida. So before starting Mobile Ad Hoc Networks, we just want to give some introduction of the ad hoc networks and mobile wireless networks. So we all are knowing that what is the wireless network. Wireless networks is simply we are representing that there is no need of wires or no physical medium connectivity in case if there is requirement of any physical medium, then it will not be saying as a wireless. So definitely wireless means there is no need of wire in case of the wireless network. So before the discussion of ad hoc networks, we should know that the wireless networks we can define in two types. Firstly, on the basis of the infrastructure based, and second is infrastructure less. So in case of infrastructure based wireless networks, what's happening that accessing points are relying on fixed infrastructure. Means there is a particular predefined infrastructure where the accessing points will be situated. From there, these accessing points should communicate to which the accessing point should communicate. Like this will be known as the infrastructure based. Base station or accessing points are fixed and centralized. So in case of the infrastructure based wireless networks, the base station or access points are fixed and centralized. As we can see the diagram, the upper one diagram, we can see that the accessing points and we can see the centralized access points that we known as a base station. These access points can communicate with other accessing points or some distant accessing points with the help of these base stations. Okay, the examples of infrastructure based wireless networks, simply we can say that wide local area networks, cellular networks, these are the examples of infrastructure based. Means there will be a fixed base station, and with the help of that base station, all accessing points will communicate with each other. Next one is infrastructure less. In infrastructure less wireless networks, there will be no centralized access points. Okay, means there will be no base station. In top most diagram, you can see that there is no centralized points, there no base station we can see. Okay, no centralized access point means there will be no base station, means the access points no need to communicate through that base station. They can directly communicate with each other, no need to controlling from a central access points or the permission required from the base stations. No need in case of infrastructure less. And the examples of the wireless networks, those are infrastructure less, are simply ad hoc networks. Now we can see here, this is the wireless ad hoc networks diagram. Here we are seeing that there is a no base station access point with which all the accessing points should communicate. At any time, these accessing points can communicate with each other. No base stations we can see here, there is no base stations. Okay, so this topology is simply known as the dynamic topology change in ad hoc networks. Means we can see in the diagram, one access point can communicate with another access points or can communicate with this access point. Means all the consecutives, all the simultaneous, all the accessing points will communicate with each other, and there is a no central control on this ad hoc network. Then we can see in this diagram that if one access point want to communicate with some distant access point, then definitely there will be a need of multi-hopping. We know that then two devising or two accessing points are communicate with each other, and if those accessing points are not in the range of the communication, then definitely we need some repeaters we need some repeaters. So in case of wireless ad hoc networks, those repeaters will be simply accessing points. Those can communicate with other access points. Means if we want to distant communication, then definitely more than one or more than two accessing points may become intermediate nodes for the proper communication. Multi-hop network that does not require any fixed infrastructure. So this is the simply in continuation of mobile ad hoc networks, that multi-hop networks that does not require any fixed infrastructure. So as we have already discussed that the ad hoc networks are not fixed. These are infrastructure less wireless networks. Peer nodes peer nodes take part in relying information, as we already discussed that for the multi-hopping, when distant point communication is needed, then the intermediate accessing points will work as a relay points. Those can communicate or those can forward the information from transmitting to receiving destination or destination point. These are simply self-organizing and self-configuring. This is the advantage of the ad hoc networks. These are self-organizing and self-configuring. Different protocols and different algorithms are utilized for self-organizing systems, for self-configuring system in ad hoc networks. Those were not in previous systems that we have seen in infrastructure based wireless networks. Situation in which useful. The ad hoc networks are useful in some situations where the setup of network fast, means like in time of emergency or relief operations. For suppose if any disaster will happen, then definitely their communication system will collapse. And when the communication system will collapse, the communication will stop. So for further communication, for improvement or for new network communication, ad hoc networks will be utilized because this networks is fast. Okay. Second one, no access to network infrastructure. Already we have discussed, not much planning can be afforded to set up the network. In case of disaster, in case of relief operations, in case of emergency, these networks are very useful because can be implemented, can be deployed very easily. Depending on topology and deployment, the ad hoc network classified as homogeneous and heterogeneous. Homogeneous networks consist of nodes having similar characteristics, that is network formed of only smartphone. In topmost diagram, you can see this is a simply a network in which only smartphones are the accessing points. So we can see that, or we can say that this is a homogeneous wireless network. In case of homogeneous wireless networks, means same type of access point will communicate with each other. Means maybe smartphone, maybe simply tablets, maybe simply phones. Okay. In case of heterogeneous, consists of nodes with different capabilities, that is network formed of PCs, smartphones and tablets. In bottom most diagram, you can see that mobiles, smartphones and tablets can communicate for forming the heterogeneous wireless network. Now, some history we want to discuss about the ad hoc networks. So, DARPA is simply Packet Radio Network project that invented in 1972. And what were happening there, that in battlefield, the communication with the devices and with the accessing points were very typical. So ad hoc networks came in scenario in 1972, when in battlefield it will be required to communicate each devices with each other. What happening in this project in 1972? Several terminals could communicate with another. Aloha project at University of Hawaii led to development of multi-hop packet radio network that is simply known as PRNet. We are just discussing about the history of this network. Aloha At the University of Hawaii, this is simply the multi-hopping, as we know that there is a no central control of any base stations. So at a time for distant communication, one access point required or need some intermediate nodes for forwarding their masses, their packets at a very large distant access points. PRNet, simply the packet radio networks, consists of several mobile radio repeaters, wireless terminals, and mobile stations. Repeaters relay packets from one repeater to another until the packet destination host. This is simply the multi-hop advantage of this PRNet project, that is simply the rapidly deployable, self-initializing, self-organizing, and no management and administration requirement. A disadvantage is what? Disadvantage was the problems with the media access. When any communication will be established, then definitely OSI model will play an important role. So in case of the media access, definitely, when there is a no central control, so for no central control in ad hoc networks, media access control is definitely was definitely a problem. In nowadays, the media access controlling, there is a lot of research work happening with media access control and for error controlling and flow controlling in case of the ad hoc networks. In case of the routing also, there were some problems in case of PRNet in history time in 1972, and after all 1980 also it was happening. But nowadays from 2000 onwards, this problem has been resolved, and the media access is now not a very big issue for the ad hoc networks in communication system. Ad hoc networks are type of distributed. This is a general concept that ad hoc networks are type of distributed wireless. So because access points are deployed in distributed manner, no predefined infrastructure, no predefined position, no predefined location. Distributing form will be used for the ad hoc network. So this is simply a typical distributed wireless network. Ad hoc networks operate in time division duplexing mode. It is not possible to receive and transmit at the same time instant. See, this is the line of 1972. In time division duplexing, one device can communicate with other in half duplexing mode. Half duplexing mode means at one time one can listen, okay, or can transmitting. So in case of 1972, in previous history or in previous concept, it was there that time division duplexing was used in ad hoc networks, but in nowadays, time division duplexing has been replaced. Now, if this is a full duplexing, if you will see in the research papers or you will see in your CDMA 2000 technology, then you can see there is a time division duplexing has been replaced with full duplexing. Okay, at same time, transmitter and receiver can receive and communicate with each other. Never node communicate with one another using wireless technology like Bluetooth, Zigbee, IEEE 8202.11 in ad hoc network. See, these are some using technologies, Bluetooth, Zigbee, and IEEE 80.11. 802.11 is basically used in Wi-Fi technology. We are using Wi-Fi technology, everybody using phones. Wi-Fi technology. So Wi-Fi technology is based on IEEE 802.11. Okay, but in case of ad hoc networks, this IEEE 802.11 will be utilized in ad hoc mode. Okay, in ad hoc means distributed mode. Now, next general concept, nodes which are distant from each other, outside from the direction transmitting range of the each other, communicate using a sequence of intermediate nodes which cooperate to forward the traffic and the destinations. Okay, so already we have discussed the general concept in ad hoc networks that multi-hopping is utilized for the proper communication. So intermediate nodes definitely will be utilized. These are some comparison of enabling technologies of wireless ad hoc networks, mobile ad hoc networks. First one technology is Zigbee. Second one is Bluetooth. Third one is IEEE 802.11. Already we have discussed. Here Zigbee, we know that the Zigbee data rate is up to 250 kilobits per second and range is 10 meter, nominal up to 100 meters. In phones we are new. And the configuration of Zigbee is a master slave configuration, long battery life. Okay. Bluetooth wireless alternative RS-232 cables. The Bluetooth standard is IEEE 802.15.1 and the data rate 1 megabits per second and the range is more than Zigbee range. Zigbee range is up to 100 and it is 100 meter and some more also can be utilized for the Bluetooth. 8 active device PicoNet scattered net will be utilized in the configuration and definitely authentication encryptions. IEEE 802.11, that is simply the enabling technology that is powering the ad hoc networks. So definitely utilize in ad hoc mode. Single hop ad hoc networks. IEEE 802.11 is utilized with the single hop ad hoc networks and the data rate you can compare with Zigbee and Bluetooth. It is a more high. This is 54 megabits per second and the range is definitely 100 to 200 meter and the configuration is peer-to-peer, definitely inexpensive hardware. Networking technologies use the one-hop direct communication capabilities to transmit the message from one place to another place, provided by the underlying enabling technologies to provide end-to-end reliable communication from sender to receiver, not in the direct communication range. Means definitely the networking technology is a multi-hop. Next, the functionings. The important functionings in the wireless ad hoc networks or mobile ad hoc networks is routing and the forwarding. Routing means in which route or with which path the message will be sent from sender to receiver. So identifying the path from sender to receiver, definitely this is a very vast area of routing in which we can see the research and we can see many research papers have been published on the routing basis in case of the wireless ad hoc networks and definitely how these messages will be forwarded. First of all, we will decide which path will be followed. These are the important function of ad hoc networks, finding out the path and then finding out the forwarding technology via which technology or with which path the message will be forwarded. So these are two important functions. On top of these, MANETs use transmission control protocols. Definitely, when we will forward the message or access point will forward the message from one place, the transmission control protocol will be utilized in ad hoc networks. These are some classification of wireless ad hoc networks. These are first one is the pure wireless ad hoc networks. Second one is mobile ad hoc networks. Third one is vehicular ad hoc networks and fourth one wireless sensor network. In first one, wireless ad hoc networks are pure in which we can see that or in which we can say that access points will be stationary. Only if access point will be stationary and the used technology is the ad hoc networking, then that network will be known as wireless ad hoc network. And second one is mobile ad hoc networks in which all the nodes may be stationary and may be mobile. So that is simply the MANETs. Next is the vehicular ad hoc networks. Vehicular ad hoc networks will utilizing or we can say on moving vehicles. If networks is formed with the help of moving vehicles or on the moving vehicles, then ad hoc networks will be known as the vehicular ad hoc networks. Fourth one is the wireless sensor network. This is simply deployed wireless sensor networks in the area where a human being is not possible to go to see the environmental condition and for the visualization of all the infrastructure. Then the wireless sensor networks will be utilized in those areas. Now, types of ad hoc networks, mobile network networks, we can see here that as we are discussing that in case of mobile ad hoc networks, all the devices may be or may not be stationary or mobile. Means stationary and can be movable. Device may be movable and stationary. Laptop may be a device there. Mobile phone, smartphone, tablets may be a device in case of the mobile ad hoc networks. Infrastructure less networks of mobile devices connected wirelessly, which follow the self-chop properties. In these types of ad hoc networks, there is self-chop properties. So, what are these self-chop properties? First one, self-chop means self-configuration. C indicating here configure, H indicating here heal, O indicating here optimize, and P indicating here protect. So self-configure, self-heal, self-optimize, self-protect. So mobile ad hoc networks are following self-chop properties. Self-configure means easily deployable with the using of different protocols, which access point, through which access point, to which access point can be decided. So known as the self-configure. Self-heal means if any access point having less battery or less power. Okay, so in case of less power node will transfer their masses to higher power node, means self-healing. Okay, so mobile ad hoc networks following the self-healing configuration or self-healing property. Next is self-optimize. Simply self-optimize means a requirement of less power. Means for communication, if the requirement of power is less, means we can say that the power is optimized. Okay, so the network is self-optimized and self-protect. Different protocols, different algorithms are utilized for self-protecting. Means for in case of hacking, we are seeing the cyber security. These security algorithms can be utilized, can be implemented in these ad hoc networks. Highly dynamic topology, which frequently changes. In case of there is because already we have discussed, there is a no central control. Okay, so within same channel without central control, there will be a requirement of different and several number of links to communicate with each other. So we can say the highly dynamic topology which frequently changes. Nodes exert routers to forward other node packets. Definitely we are talking about that access points, intermediate access point will forward the data, the packet, the information from transmitting node to this receiving node. MANET enables spatial spectrum reuse due to limited bandwidth of each node. Reuse concept also will be utilized here, because there is definitely a single channel and several devices has to utilize the channel. That means definitely limited bandwidth, and the reuse concept will be utilized in ad hoc networks. Now, the vehicular ad hoc networks. In vehicular ad hoc networks, in the diagram, we can see that there are some vehicles, and these vehicles are communicating with each other with the help of roadside access points. These roadside access points, we can see these are the roadside access points, and definitely there is a access points or wireless enabling devices are implemented on these moving vehicles, and these vehicles can communicate with each other, and these information can be passed or can be sent through the roadside access points, and the short form of vehicular ad hoc networks is known as a VANET. Spontaneous data exchange between vehicles, key components of intelligent vehicle system, definitely. At if one vehicle will want to communicate with each other or any different vehicle, then definitely some intelligent point or intelligently access points will be implemented on both vehicles and communicating vehicles. Uses variety of communication technologies, short range technologies like WLAN, okay, wide local area network, Bluetooth or Wi-Fi technology. Definitely 802.11 technology protocols will be utilized in case of Wi-Fi, cellular technology like LTE. Long-term evaluation technology consists of both inter-vehicle, that is simply V2V communication, and vehicle to other infrastructure, that is V2I communication. Different than MANET in that they follow the predictable patterns, that is the longer road. Now, see, in case of the vehicle networks or in case of the vehicle ad hoc networks, every vehicle will predict which vehicle is going forward or which vehicle is going backward. Okay, so this is some intelligent access point that will be implemented or that will be imparted to the vehicle ad hoc networks. So it is different than the mobile ad hoc networks, because there we are not using or no intelligent device is utilized in case of mobile ad hoc networks, but here it is utilized. Very high mobility, much greater than thousands. Now, advantages: cooperative driving, information sharing and media streaming, value added services like internet access and navigation. Okay. Now, components: onboard units, that is responsible for the data collection from different sensors and communication with other onboard units. Roadside units, infrastructure which enables communication to the outside network. Communication technology, wireless access in vehicular environment, that is known as a wave. So wave is definitely in case of wireless or ad hoc networks, wave. This is the wireless access in vehicular environment. Wave is a very interesting research area. Lots of papers have been published in wireless access in vehicular environment. Supports multi-hop communication between vehicles, and the standard utilized known as DSRC 802.11p. In Wi-Fi, see here, the Bluetooth and Wi-Fi technology utilizing 802.11. So in case of the vehicular ad hoc networks, the some improvement that DSRC 802.11p for the communication. This is some infrastructure domain in which the vehicles can communicate with each other. See, this is here RSC, roadside unit. This is onboard unit. Okay, this is V2I, vehicle to infrastructure communication. V2V, vehicle to vehicle communication. This is trusted platform module. This is a trusted platform module with which or with the help of TPM, the vehicles can communicate with the application on infrastructure domain. In infrastructure domain, the vehicles can use or vehicles are utilizing the trusted platform module for communicating or sending their message or sending their sensed information with the help of RSU to the applications of infrastructure domain. Some comparison of MANET and VANET, vehicular ad hoc networks and mobile ad hoc networks. Metric cost of deployment, comparatively cheap, high mobility scenario, low and very high, definitely. Frequency 2.4 gigahertz and infinite 5.9 gigahertz. And the technology definitely used, that is their ad hoc mode, 802.11 ad hoc mode. And in case of vehicle ad hoc networks, 5.9 gigahertz. And already I told you that this is a very interesting research area. And the range 100 meter, 1000 meter. Partitioning of the network low and frequent. Definitely on road, the number of vehicles are increasing. So the partitioning of the networks will be frequent in case of VANet. Mode of operation, infrastructure less. And in case of the vehicular network, both are possible. Because we know that the where the roads are situated, okay, where the roads are situated, in which directions roads are going. So definitely we can say that the vehicular ad hoc networks may be the type of infrastructure based or infrastructure less. Movement pattern of the nodes, definitely in case of the mobile ad hoc networks is random, and the VNet, it is constrained by the road. Next, ad hoc networks we can discuss as the wireless sensor networks. Also, this is a type of ad hoc networks consisting a large number of sensor nodes densely deployed over an area. In case of MANET and in case of VNet, in comparison of both, wireless sensor networks are densely deployable. Okay. Sensor nodes are capable of collaborating with one another and measuring the condition of their surroundings environments, light, temperature, sounds, and vibrations. Okay. As in starting, we have discussed that some areas, okay, where the human being not possible to supervising, their sensor nodes or sensing elements or nodes point like sensing elements, light, temperature, sound, sensors utilized to overlook or to supervise the environment. Okay, so wireless sensor networks are deployed in those areas where the easily deployment or easily supervision is not possible. The sensed measurements are then transformed into digital signal and processed to reveal some properties of the phenomena around sensors. Okay. Due to the fact that sensor nodes in wireless sensor networks have short radio transmission range, intermediate nodes act as a relay nodes to transmit data towards the sync node using multi-hop pathing. This is the simply concept of wireless ad hoc networks, like in case of and wireless sensor networks also utilizing this multi-hop communication. Small size, typically less than a cubic centimeter, and has embedded OS like tiny operating system. Must consume extremely low power, should be autonomous, that is operate on an unattended manner in a high densed area. Wireless sensor networks can be either mobile or stationary. So these are some important ad hoc networks, and we have compared the different ad hoc networks. Thank you for watching this video. Thank you.